Welcome back. I believe we've got a caller on the line. Agnes, are you there? Okay, we're waiting for Agnes. Oh, while we're waiting for Agnes, Agnes, are you there?
Yes, I'm there.
Hi, Agnes.
Hi.
Welcome. I believe you've got a question about the GDE paper 2, question 4.
Yes.
Okay, should we read the question through and then you can tell me what the problems are? So let's...
Yeah.
Right, Gavin has a pizza oven in his lapa that he wants to paint. The heat-resistant paint that he's going to use covers 0.5 meters squared. I think I need a color for that. 0.5 meters squared per liter. He only needs to paint one coat of paint. Right, and then they give us this picture of the pizza oven. So does this look kind of scary, Agnes?
Yes.
Okay, so we need to go through this one step at a time. Now, before I carry on with Agnes, I just want to go through. They've given you, right, a sphere, well, a half a sphere. It's got a cylinder, which is where your smoke comes out, and there's a door opening. So if we read through the formulas that they've given us, we've got the area of a sphere, we've got an area of a cylinder, and we've got the area of a circle. And then they say calculate how much paint is needed to paint the pizza oven and show all your calculations. And then they've given us 27 marks for this. So they kind of don't break it down for us. So Agnes, how would we start?
I'm going to say the area of the animal in the sphere is called to 4 pi r squared.
Okay, so
Radius squared.
if I can hear you correctly, I can't really hear you very well. Let's find some more space. So we know that our sphere, the area for that is 4 pi r squared.
Yes.
Okay, so let's calculate a full sphere. Let's calculate the area of a sphere, Agnes. So how would we do that? What on my sphere, we're looking for my radius. Where is the radius on the sphere?
0.6 meters.
You say that the radius is 0.6. So you took this and you divided by 2.
Yes.
Agnes, before we carry on, if I had to draw the entire sphere, and I've got from there to there is 1,2. Is that giving me the diameter, which is what you've looked at, or is it giving me the radius?
I didn't hear you. Please repeat the question.
I said our 1,2 is basically from the ground up to half the sphere. Is that the diameter or is that the radius of the sphere?
I think it's the diameter.
You think it's the diameter. My diameter would go right through my entire sphere. Can you see that that would be the diameter? But in actual fact, what I have is I only have half of that. I've got from the ground going up to the top.
Okay.
So can you see that my 1,2 is in fact my radius?
Okay.
Okay, and I think that that's probably the first problem that Agnes, and not Agnes, you're not alone. There are a lot of people that have picked up that that is the first problem that we've experienced. Because when we've got a picture of half a sphere, then from the ground up to the edge of the sphere will actually be the radius. Because your best bet is to draw the entire sphere and then see what measurements we've got. So okay, now we've decided what the radius is. Let's substitute that into my formula. So we're going to calculate the area of the sphere, and it tells me to use pi equals 3,14. So I'm going to do that. And my radius we said was 1,2 squared. Happy with that, Agnes?
Yes.
Okay, so let's calculate that. So on the calculator, I'm going to say, well, it's 4 times by 3,14 times by 1,2 squared and get an answer. Right, so I've got 18,0864. I'm not going to round off quite yet. Are you happy with that, Agnes?
Yes, I am.
So it was 18, now I've forgotten what that was, 0864.
Yeah.
But what's the problem with this, Agnes? Can we see a problem?
Yes, I can see it.
What's the problem?
No.
we don't have a full sphere. We only have half a sphere. Am I right?
Yes.
So how are we going to change that to half a sphere?
Sorry?
How are we going to change our full sphere into half a sphere? We're going to
divide
it by 2.
Yes.
So let's do that on our calculator. We're going to divide our answer by 2, and we get 9,0432. Again, I'm going to keep 9,0432. I'm going to keep all the decimal places. And guys, I want you to be aware of this. Only round off at the very end of your question. Please, it's important. So we know that that is our sphere. Right, let's go back to the diagram. What should we calculate next?
The cylinder.
We're going to calculate the
cylinder.
The cylinder. So we're going to calculate the cylinder. Okay. Now, our cylinder, we've got our formula. 2 times pi times r times h. So let's go through and work out our cylinder. So my formula is 2 pi r h. Now let's substitute in. So we've got 2 times pi is 3,14. What is my radius of my cylinder, Agnes?
The radius for?
My radius for my cylinder. This 0,3, that's giving me 0,3 is giving me my diameter.
0,3 means.
So I'm going to say 0,3. I think we need to divide it by 2. Because 0,3 is from one edge to the other edge, and we're looking for the radius, which is from the center to the outside. So we're going to say it is 0,15. Are you happy with that, Agnes? So we're going to substitute that into our cylinder. So our radius was 0,15. That's not how you write 15. And my height of my cylinder is given to me over there, 0,5 meters squared. 0,5. That's perfect, Agnes. So now let's substitute all that into my equation. So I've got 2 times by pi times by my radius times by my height. What was that height? It was 0,5. And I get an answer of 0,471. Perfect. So you're on track there. So let's write in our answer here is 0,471. Right, what's the next step that we need? So let's actually analyze what have we got so far. Let me take those away. We've calculated the cylinder. We've calculated the sphere. What do we now need to actually do?
The circle.
We need to calculate
the circle.
The circle. We've got 2 circles, in fact, to calculate. We need to calculate the door of the pizza oven because we can't paint that. And we need to calculate the top, the roof, which is actually, I'm going to take away these colors, which is actually that part over there. So we need to calculate 2 circles. Can you see that?
Yes.
Okay, so let's do the one. And we're going to go through what formula have we still been given. We've been given the formula of pi r squared. And it's a nice way to check that ensure you've used the formulas they've given you, because they're going to give you the formulas that are there to help you every step of the way. So we've got the area of the circle. So we've got 2 circles. We need to work out the circle. Let's do of the cylinder, circle in the roof. Let's do that one first.
The first one of the roof.
We're going to do the circle of the roof.
Okay.
This one over here. Right, so what do we need there? Our formula is pi r squared. We're using pi is 3,14. And what is my radius? Well, we calculated our radius earlier. Do you remember? 0,3 was the diameter. And
0,15.
0,15. So that is 0,15 squared. So now let's get the calculator out. So I've got 3,14 times 0,15 squared. And I've got an answer of 0,07065. 0,07,065. Have I written that correctly, Agnes?
Yes.
Okay. Now, what other circle do we need to calculate? We had
0.6 diameter.
We need the door. Okay, so that's pi r squared. Let's go back up to the picture. You're right, our diameter is 0,6. So what is my radius for the door?
0.3.
0,6 divided by 2. Perfect, 0,3. So I'm going to work out this area of the door, which is 3,14 times by 0,3 squared. Right, let's do that on the calculator. So I've got
0.2826.
Oh, you're ahead of me. 0,3 squared is, what did you say, 0,2826?
Yes.
That's what you got. What is the problem that we've got? Little problem here. 0, comma, can't remember what they are. 2826. 2826.
2826.
What's the little problem that we have here with this answer? That is an entire circle.
Oh, yes. We must divide it by 2.
We must divide it by 2, Agnes. Perfect. So we're going to divide this by 2. I'm going to use my calculator. 0,1413. Are you?
Yes.
Okay, so we've got, need a pen for that. 0,1413. Right, I haven't put in any units, but I haven't rounded off either. I can do my units right at the end, but don't forget your units. Right, Agnes, now what have we got? So we've got our sphere. I'm going to change colors here so we can see it. I've got my sphere.
Yes.
I have my cylinder.
Yes.
I have the circle of the roof and the circle of the door. So how am I going to put this all together? Let's erase all our colorings here and see how we're going to put this all together. So we're going to say the sphere. Am I right?
Yes.
It's sphere. Let's write that as. So we're going to take the sphere. We're going to add the cylinder. Am I right?
We're going to add it.
We're going to add. We need to add the sphere and the cylinder. And then the door, what are we going to do?
We also add the circle of the top sphere.
Are we going to be painting the door, or are we going to be eliminating the door? There's nothing actually here, so we're going to be minusing the door.
Minus.
Because the door does not exist, it does not need to be painted. And the same thing with the top of the roof here, we're going to minus the roof. Does that make sense, Agnes?
Yes.
Okay, so let's do that. We've got 9,0432, 9,0432, plus I'm going to add the cylinder 0471, and then I'm going to minus the roof, which was my 0,07, let's go up a little bit, 065. And then I'm going to minus the door, because that's the only way I can get just the pizza oven. And let's do that on our calculator. So I've got, excuse me, 9,0432 plus 0,471 minus 0,070665 minus 0,1413. And I get an answer of 9,3. At this stage, I can round off my answer. So my answer is 9,30. Sorry, let me have a sip of water. 9,30 30, oops, lost that. A calculator, 9,3, and I've written 9,0. 9,30. Happy, Agnes?
Yes, I am.
What is that? 9,3 what?
9,30.
30. What unit are we dealing with?
Meter.
Meters, and its
Yes.
area? Meters squared. Perfect, Agnes. Have we actually answered the question though, Agnes? Let's go back and double check. We've worked out our area. It says calculate how much paint is needed to paint the pizza oven. We have worked out our area. We haven't worked out the paint. So we're going to need to use that fact that the paint covers 0,5 meters squared covers 1 liter. Are you happy with that, Agnes?
Yes, I am.
Okay, so how are we going to do that? We know our area. What are we going to do? I think maybe we will divide it by,
Sorry?
we're going to divide that by the amount of paint that will be covered per liter.
We're going to divide 9,30 divided by 0,5.
That's exactly what we're going to do.
Okay.
So let's do that. We've got 9,3, lost my calculator, 9,3, and we're going to divide it by 0,5, and we end up at answer of 18,6.
18,6.
So what is that 18,6? 18,6?
18,6 liters.
6 liters. Absolutely.
But it is impossible to have an 18,6 liters.
Absolutely.
I think it's going to be 19 liters.
We're going to make it perfect, Agnes. I'm very happy to hear that. We cannot have a 0,6 liter. So we actually need 19 full liters of paint. Well done, Agnes.
Thank you.
Right. Do you want to go through and do the second part of the question?
Yes, I do.
Okay. Right. The next part of our question says the recipe for a successful pizza base is given in a magazine and reads as follows. So we're looking at one base, 100 grams of self-raising flour. Agnes, I think when we finish this question, we must go and make some pizza. We've got the recipe now. Right, we need to know is calculate how many cups of flour is needed to make 12 pizzas. And we want to know cups of flour. So we know that 10 grams is equal to 25 milliliters, and 250 milliliters is 1 cup of flour. So what are we going to do first, Agnes?
Let me see. 10 is it?
Right, I think what we're going to do first is check how much flour we need for one pizza. So for one pizza, we need 100 grams of flour. Are we happy with that? So let's write that out. We know that for one pizza, we need 100 grams of flour. So we can do two things now. We can actually calculate how much 12 pizzas, how much flour in grams, or we can convert to milliliters first, because we know our answer needs to be in milliliters. Are you happy with that, Agnes?
Yep.
So which would you like to do? Should we convert first?
Let's start with conversion first.
Okay, so let's convert first. So we know that 10 grams is equal to 25 milliliters. Now I want to know what 100 grams is equal to how many milliliters. So what are we going to do here? Well, I need to look at what did I do here to get from 10 grams to 100 grams.
Look.
Can we see that we multiplied by something?
What by 1,000?
We multiplied. If we multiply 10 by 1,000, how many are we going to get? And to get more than 100. So for you to work out what we did, let's do the reverse. Let's say, well, 100 divided by 10 will give me 10. So I can see if I take 10 and times by 10, I will end up with 100. So I've times by 10 over there. And what I do to the one side, I need to do to the other side. Happy with that?
Yep.
So 100 grams is actually going to be equal to 25 moles times by 10. So 100 grams is actually equal to 250 moles. So one pizza is actually 250 moles. I also know that 250 moles is 1 cup of flour. So I can at this stage say that for one pizza, I have 1 cup of flour. Are you happy with that?
Yes.
Now how many pizzas do I need to make? I need to
12.
make 12 pizzas.
12 pizzas.
So how many cups of flour have I got? For 12 pizzas,
Sorry?
how many cups of flour? For 12 pizzas, we're going to say, well, 1 cup for every pizza that I make, and times it by 12 pizzas. So I need 12 cups of flour. Are you happy with that, Agnes?
Yes.
Perfect. Okay, that takes us to the end of our question. So it was nice chatting to you, Agnes. I hope that I've helped you a lot. And if any of you out there want to phone, please do so. It's 086 10 58 262. And I hope to speak to somebody else soon. And we're going to take a short break now.